Hi everyone, my name is Patrick, and today I'm going to go over the basic wind analysis for your technology module. There are two ways in which I know that would help. There are two ways that I know that would help you visualize your building's aerodynamic response to the environment. You may build your own wind tunnel, which is kind of what we did in my technology unit. And using basic acrylic and laser cutter, you'll be able to create a very basic aerodynamic tunnel that will help you visualize the aerodynamics. Or you can use CFDs, which is basically computational fluid dynamics. And within architecture, CFDs are usually used to study the wind and temperature, ensuring the visitor's comfort and the structural integrity of the design. When analyzing wind within architecture, the main three evaluations that you should be considering are the wind comfort at the pedestrian level. So if a design funnels the wind into a bottleneck, it will accelerate the wind speeds beyond comfortable level, just as it can be seen over here, where the wind speed starts at a certain level and then it gets multiplied in the center. We can also look at the wind load, or the pressure at which the wind will be applying onto the facade. So if a facade is considerably higher with pressure, it may be difficult to open doors, or it may force itself into the building, forcing natural ventilation. And if you want to model the interior, you can also test out natural or mechanical ventilation. So the software that we'll be using today is called ANSYS Discovery, a student version. The software contains fluid flow dynamics, along with a few other features which won't be covering today. Previously, you've seen my work in Autodesk Flow Design, which has recently been discontinued, so we won't be able to. You won't be able to replicate the same results that I have. But this program seems to be doing a very similar job. So to install the software, this software I found is kind of buggy in some areas, so you won't be able to import it at scale 1:1 because it will glitch and it won't do any analysis at all. So we'll be importing it at a smaller scale, so the values such as the pressure will not be correct, but the wind flow should be pretty much accurate. So the software, as I mentioned, is called ANSYS Discovery Student, and if you type in ANSYS Discovery Student, you'll be able to go into the first link, and as you scroll down, you will be able to see prior releases. Now, for some reason, the latest revision, the 2.1, doesn't seem to work without the first release. So you are going to have to download the Discovery Live Student 2021 release 1. So once you click on that, it's going to download this large file, and also the release 2.1, because it's less buggy than the 2.1 than the R1, but this one requires the R1 to even function properly. If you just download and install the 2.1, you will end up with a licensing error for some unknown reason. So I've already got these downloaded. Once they're both downloaded, make sure you click the R1 first, and you should end up with with something like this. Now extract it to a desired folder. It can be absolutely anywhere. So I already have it extracted on here, and then click install or set up as an administrator. It will come up with a window of how to install, and all you have to do is constantly press next when it comes up. There we go. So just agree, next, 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 and that's pretty much it. You do this to the R1 version and then to the R2 version. When you have them both installed, then the R2.1 should open up with this little icon on the top right corner showing you that you're a student. Okay, so that's pretty much how to install this. When you first install it, you'll be greeted to an empty page or to a home page, which is going to look something like this. You can either play about with the samples, see what the software is capable of, or we can go straight into the new. So we can import geometry by going into these three lines and clicking on insert geometry, and then we can import anything you like. The software seems to be working with .obj files and .stl files, as well as 3DM files from Rhino and even SketchUp. So feel free to import whatever files you want. For now, I'm just going to import this basic block and just zoom out. There we go. That's pretty much what we've got here. So there is a couple of ways to set up this analysis. The simplest one is by just going into simulation and going in quick start, clicking external flow, selecting exactly where you want the flow to come from, and selecting the base, so the floor, the ground. When you click on that, you're going to have a big box come out around it. And this is the simplest way, and it's pretty much done. All you have to do right now is just click on the solve on the bottom right corner, and it should start the simulation right away. But what we have to do now, one of the important steps, is to change a few things. So one of the things is that this is initially done with water. So if you just right click on the water on the top left corner, click edit, change it from water to air. And also from the flow inlet, using your program, you'll be able to find out the wind speed that you are working in. So I think it's going to be something like 10 meters per second. And you'll be able to get a somewhat accurate representation of how the air flows around it and how many turbulences you've got behind, etc, etc. There are different visualization methods on this program, so these are just streamlines. You can change the count of them or the thickness of them, or what you can do is also select other methods such as these balls or the directional fields. Now you can rotate these. If you don't like the location of this, you can click on that little ball. Make sure you click on it, because otherwise it just disappears, and then you can rotate it. Move it up and down. And that would be the simplest way to find out the pedestrian level speeds. So as you can see over here, we've got a pinch point where the wind enters at 10 meters per second. However, because the building is not aerodynamic, it creates a very high speed, almost double the speed over here, and a lot of turbulences in the back. So we ideally want to avoid that, avoid those kind of areas. So that's the basic way to do this, and let's go through other things. We can also show you the ISO surface. So if the wind was to approach the building, this area is essentially flown over. It's kind of the most aerodynamic shell. So this would be the area of low pressure, and this would be the area of high pressure or high velocity. And also we can also check the pressure on the faces. So we click on the contours, click on the inner, and from over here we want to change from velocity to static pressure. Now we can see which areas or which faces receive quite high pressure from the winds. And if you get stuck rotating until you get upside down, you can also use this box over here, or this cube, to rotate yourself around to get yourself out of tricky situations. Also, you can click on home view or different types of views. One way to export this view, if you are happy with the view that you're looking at, is to go over to Simulation tab, Scene, and export to 2D image, and this will export your screen that you're currently looking at. So there are some things that I have missed out in the previous section of the tutorial, and I just wanted to address some of them. If your model does import sideways, for example, you can click on the project browser on top of the corner, click on your model name. It should come up with your gumball, but if it doesn't, you've got under design tab, edit, move, just click on move, and this should pop up again. So then we can just drag it down to 90 degrees and rotate it accordingly to where you want the wind to come from. So if you wanted to go directly onto that face, sort of keep it that way. Now there are other ways of creating this wind tunnel, making it more manual, adding some walls into it, but it's, for some reason, it doesn't work very well for me. So you can click on prepare, click on enclosure, and set up your box however you like. However, for some reason I can't seem to select the flow walls or anything like that, so I will generally try to stick to the quick start external flow. This seems to be working fine, and you'll be able to complete the task successfully. This does everything. It already does the inlet, already does the outlet, which is what we would be setting up manually, but it actually works. So let me just change that down up to 10. Let me just change that quickly to air. And we've got the area, so now we can just click and start. And it should start its analysis. Now, the one thing that I also forgot to mention is how to make these streamlines a little bit smaller. So when you click on, click and drag on this circle, you can actually make it smaller. You can make it almost flat if you wanted to. And if you click on a ball, make sure you click on the ball, because if you don't, it's going to constantly disappear. Click and drag down. Let's see if anything flew inside. No, it seems to have completely avoided it. So let's have a look why to do that. Okay, that's because it was slightly too high, as you can see. Now when you scroll down, you can see the air going inside and how it goes through. How it flies through. So yeah, I hope that this tutorial helped you figure it out. Just don't forget to save into 2D images and put them into your design development, showing how it all looks, how you developed it, how you approached it. And that is basically it. I think I have shown everything that this software can do. If there are any questions, let me know. You should have my email. If anything, it's up785356, and if you struggle with the software, or if there's anything that I can help out with, just send me an email and I should be able to reply to you and figure out if there's any issues. Thank you.